Hello everyone, my name is Suresh. Now I am going to present on 6 Easy Pieces by Richard Feynman. Richard Phillips Feynman was an American theoretical physicist. He is well known for his work in the field of quantum electrodynamics. He received Nobel Prize in Physics in the year 1965. He helped to build the basics of new physics. His contribution touched almost every corner of the subject and have had a deep and abiding influence over the way that physics think about the physical world. He was a good teacher of his era. It was Feynman's outrageous method of teaching that has gained him legendary status among students and professors of physics. He has a special way of explaining most complicated concepts in a simple way. Current work, Six Easy Pieces, is the six easiest chapters from the Feynman's text, the Feynman Lectures of Physics, originally published in 1963. The uncertainty in the laws of physics and how they are modified were explained. Then author explains what are the concepts that are known and how accurate they are and how they are evolved from the past. Now coming to the atoms in motion. Atomic author felt that atomic hypothesis is one of the most important concepts. All things are made of atoms. Atoms are little particles that move around in perpetual motion, attracting each other when they are little distance apart and repelling upon being squeezed into one another. The, the atoms are always in motion. The motion of the atomic particles and how it impacts the material properties is explained by taking water molecule as an example. And then the perpetual motion of these atomic particles is called as Brownian motion, and this was uh, explained clearly explained by the author. Chemical reactions that are involved in the elements are basically that occur due to rearrangements of the atomic partners, and the factors influencing the reaction such as temperature, pressure, and all were explained in the author. That they are how the laws of physics were developed was explained how and how they are modified from the past experiences were also elaborated. The fundamentals of the physics such as experimentation and imagination were elaborated. Uh, The phase of the physics before the invention of quantum mechanics was explained, and then the changes that quantum mechanics has brought upon has been dealt. After the invention of quantum mechanics, the inertial forces and Newton's laws were felt to be wrong in the world of atoms. Uh, it is found that the things on the small scale behave nothing like things on the large scale. One of the consequences is that things which we use it to consider as waves also behave like particles, and particles behave like waves. In fact, everything behaves the same. There is no distinction between a wave and a particle. So quantum mechanics unifies the idea of the field and its wave and the particles all into one. The of physics with other sciences has been discussed. Physics is the most fundamental and all-inclusive of the sciences and has profound effect on all scientific development. In fact, physics is the present-day equivalent of what used to be called natural philosophy, from which most of our modern sciences arose. Students of many fields find themselves studying physics because of the basic role it plays in all phenomena. There was an early relationship between physics and biology, in which biology helped physics in the discovery of conservation of energy. which was first demonstrated by Mayer in connection with the amount of heat taken in and given out by a living creature. Similarly, the relationship with astronomy, psychology, and chemistry were also discussed. Law of conservation of energy. It says that there is a certain quantity which we call energy that does not change in the manifold changes which nature undergoes. The types of energy are gravitational energy, kinetic energy, heat energy, elastic energy, electrical energy, chemical energy, radiant energy, nuclear energy, mass energy, etc. There are other two types of conservation laws which are analogous to conservation of energy. One is conservation of linear momentum and another is conservation of angular momentum. Here, the author explains this with a good example of a simple pendulum. Theory of gravitation. Galileo discovered a remarkable fact about motion, which was essential for understanding these laws. That is inertia, uh, principle of inertia. If something is moving with nothing touching it or completely undisturbed, it will go on forever at a uniform speed in a straight line. And Newton modified this idea as saying that only way to change the motion of a body is to use a force. Quantum mechanics. Quantum mechanics is the description of the behavior of matter in all its details and in particular of the happenings on an atomic scale. The electrons arrive in lumps like particles and the probability of arrival of these lumps is distributed like the distribution of intensity of wave. It is in this sense that an electron behaves, sometimes like a particle and sometimes like a wave. This is explained with a experiment using a gun and a bullet. Uh, Heisenberg's uncertainty principle or the double slit experiment, which showed that at the quantum level, particles behave both waves and particles. Thank you.